Okay, we're moving on to Chapter 9. The first section of Chapter 9 is called Altitude on the Hypotenuse. I'm going to call this section Sunshine, and hopefully in just a little bit you'll see why. It starts out, we're going to start out here with an opener, and the opener actually is a connection to the previous chapter. The previous chapter was all about similarity, similar triangles, and in this particular section, we're going to do a problem here first that has to do with that. So here you have a right triangle, and there's an altitude drawn to the hypotenuse of that right triangle. So this is the altitude that is drawn to that hypotenuse. When you have this situation, what you actually end up with is you end up with triangles that are similar to each other. So AUT is similar to ATS because of AA. They both share angle A. It's reflexive, and they both have right angles in them. And in fact, if you remember from last chapter, all three of these triangles are actually similar to each other. This side here, AS, is 12. AU is 8. What we're looking for is AT. We'll call it X. Now I can set up a proportion based off of the similar triangles. I know I can do, for example, for the smaller triangle, so for this triangle here, if I focus on that triangle, I know I can write a ratio of 8, which is the longer side of longer leg of the right triangle, of that right triangle, over the hypotenuse, equals, and then if I focus on this big right triangle right here, I know that the longer side of that right triangle is X, and the hypotenuse is 12. And if you notice here, we've got a nice little proportion we can set up, or we can cross multiply with and solve. So I get x squared is equal to 96, 8 times 12, and then x is equal to the square root of 96. So that's the answer to AT. Now, looking at the square root of 96, I can simplify this, and in fact I'm going to simplify this. I know it's going to be 4 root 6. And I'm going to review how we got from here to here down below. Okay, but keep this particular problem in mind as we move on to the second page and we talk about sunshine. Okay, let's move down and let's review radicals, because in this particular chapter, my expectation is that you're going to be doing you're going to be getting radicals for answers, and you're going to be simplifying them. So for example, the square root of 24 is equal to, and what I'm going to look for here is I'm going to look for the largest perfect square factors of 24. So the largest perfect square factor of 24 is 4. So in other words, I can write this as the square root of 4 times 6, or the square root of 4 times the square root of 6, or 2 root 6, like that. You don't have to show all that work there, but I am showing the work just for your sake in following along. So the square root of 72, I'm looking for the largest perfect square factors. Let's say that you don't see that 36 is actually a perfect square factor of 72. And instead you happen to spot that it's going to be the square root of 9 times 8. By the way, perfect square factors are numbers like 4, 9, 16, 25, okay, 36. So it's the square root of 9 times the square root of 8 equals 3 root 8. And hopefully you can see here, and hopefully you spot that the square root of 8 is not simplified all the way, because there's a perfect square factor of 8, which is 4. So it's going to be 3 times 2, or 6 root 2. Okay, because square root of 8 is just 2 root 2. If I look at something like this here, I can simplify some of this. I can add these two together. Think of these as x and x, and this would be like a y. You can combine these together. That would be 6 root 3 plus 6 root 5. And because the radicals aren't the same here, you cannot combine those. I could factor out a 6 if I wanted to, but I'm not going to do that. I think that's it for that. I'm going to move on to this concept down here. Let's go after problems 1 and 4. So problem 1 here, I can simplify this to square root of 7 over square root of 32, which is the square root of 7 over 16 is the largest perfect square factor of 32, so it's going to be 4 root 2. And this is called rationalizing the denominator. So I'm going to multiply this by root 2 over root 2. I'm allowed to do this because this whole thing is equal to 1. And so I'm going to multiply it by 1, which is going to change what it looks like but not change the value of the answer, of the final answer. So it's going to be square root of 7 times square root of 2, which is square root of 14. And then on the bottom it's going to be 4. Now keep in mind that the square root of 2 times square root of 2 is just 2. Square root of 5 times square root of 5 is just 5. Square root of 1 zillion times the square root of 1 zillion is just, of course, 1 zillion. Okay. So it's going to be 4 times 2, or 8. So it's the square root of 14 over 8. And down at the bottom, same type of problem where I'm rationalizing the denominator. It's going to be multiplied by the square root of 2 over square root of 2 again. It's going to be 28 root 2 over 10. Now you have to simplify this portion, the fraction, and that's just going to be 14 root 2 over 5. Oddly enough, when you get to calculus, you're going to be rationalizing the numerator sometimes. But for now, I'm going to expect you to rationalize the denominator as you simplify. And unfortunately, yes, you will lose points if you don't rationalize the denominator or simplify the radical, which is what we were doing up above here in this part. Okay, let's move on to the next page. Okay, so this is the main theorem from this section. Basically, whenever you have a situation like this, you have a right triangle. So this is a big right triangle with an altitude drawn to the hypotenuse of the right triangle. So here's the altitude drawn to the hypotenuse of the right triangle. So whenever I have this situation, as I mentioned on the front side, there's going to be 3 similar triangles formed. There's going to be the big triangle, so triangle ABC. And it's going to be similar to triangle, let's make sure we get the letters right, it's going to be similar to the triangle on the left here, so ACD, just matching up letter angle A and the right angles, so C and D are the right angles. And then that's going to be similar to triangle CBD. Now again, the order of the letters there is very important as we write that out. Now, what we want to do here is identify the mean proportional relationships. So mean proportional is the same thing as geometric mean. So in other words, you want to have in this proportion, so you have 4 spots, you want to have these two be exactly the same. So if I look at this thing, one of them is going to be x over b is equal to b over c. Okay, and again, I'm looking at little letter b, and it's going to be opposite of big angle B. Little letter c is opposite of big angle C, and little letter a opposite of big angle A, like that. Okay, so that's where all the small letters are coming from. And another one is going to be y over a is equal to a over c. And the last one is going to be x over h is equal to h over y. And if I look at this thing, I can go ahead and cross multiply, and you can see that the relationships are going to be, for this first one, it's going to be b squared is equal to x times c. And for this one, the middle one, it's going to be a squared equals y times c. And for this last one here, it's going to be h squared equals x times y. And so what I can do is, if I'm approaching a problem that has this diagram, I can go ahead and I can find all, I can use these relationships to solve for certain sides of within that diagram. Or I can go ahead and use these relationships down at the bottom. And what I've done with sunshine, actually, sunshine is actually something I learned, true story. I learned from a student who moved into my class maybe, I don't know, 10, 12 years ago, and she had this little trick to remembering these relationships, and the little trick she learned from a tutor, and I think I called the trick sunshine eventually, but I kind of looked at what she did and I kind of said, well, it's alright, but then I found myself using it the year after, and it works for me at least. So here's how this works. So this little side is going to be A, this little side is going to be B, this big side is going to be C, let's call this X, let's call this Y. Okay, what you have to do here is you have to pretend that the hypotenuse of the big triangle is the ground. So I'm going to use some grass here to indicate that it's the ground. And then if I put the sun up on this side over here, and it's shining down on this side of the diagram, I'm going to ask myself, so it's shining on the A side, so that's going to be my A squared. I'm going to ask myself, where are the possible shadows for side A along the ground? Well, my shadow could be Y, depending on exactly where the sun is, if it's a little bit this way or if it's a little bit this way. Or it could be the entire length, which is C. Let's put the sun on this side of the diagram. So the sun is shining down on that side. So that side is side B, so it's B squared. And we have to ask ourselves where the possible shadow is going to be for this. Well, it could be possibly here, or it could be, depending on where the sun is, all the way along the bottom there. So it's going to be X times the entire length of the bottom, which is C. And then here's where it's a little bit of a push. I'm going to put the sun up here, and it's going to shine. I'm going to shift it either to my right or to my left, and it's going to shine on this piece right here. Let's call it H. So it's going to be H squared equals, now if it's a little bit to the left and it's shining down this way, my shadow is going to be along the bottom here, Y. Or if it's a little bit this way and it's shining this way, my shadow is going to be X. And there's my three relationships, which are the same as these three relationships here. Okay, so let's try applying this to a few problems, two simple problems. So if I look down at the bottom here, if I'm looking for X, what you have to do sometimes is kind of flip your paper over, but hopefully you can see, I'm not going to be able to flip it over because this is my computer. Hopefully you can see that that's the ground. And so if I'm looking for x, x is going to be the one that's straight up and down. It's my altitude. My relationship with the sun up here, and it's going to be a little bit this way, a little bit that way, it's going to be x squared equals, and then if I shine it this way, my shadow is going to be 5. And if I shine it a little bit this way, my shadow is going to be 4. So x is going to be equal to the square root of 20, and here's where simplifying the radical comes in handy. Square root of 4 times square root of 5, so it's going to be 2 times the square root of 5. Now to find y, put the sun right here, shine it this way on y. Here's a short shadow, here's a long shadow. So it's going to be y squared equals 4 times 9, or y is equal to the square root of 36, which is y is equal to 6. And so that'll be the answer to y. And then for z, I'm going to put the sun right there. I'm going to shine it down on this side, so it's going to be z squared is equal to the short shadow times the long shadow, so it's going to be 5 times 4, nope, 5 times 9, or the square root of, or 45, so z is going to be equal to the square root of 45. Or if I simplify that, it's going to be 3 root 5. And so that'll be the length of z. Let's try another one here. So CD is 8, and BD is 16. I want to find AD. Let's call that x. So hopefully you can see that it's 8 squared is equal to 16 times x, or x will be equal to 4. And then it's a separate problem using the same diagram. AD is 3, and BD is 24. Find AC. So let's call this side y. So y squared equals, remember this is the ground here, y squared is equal to the short shadow, which is 3, times the long shadow, which is 27, or 81, 3 times 27, so y is equal to 9. Okay, let's go to the back side, or to the next page, and try a couple of harder problems. Alright, I want to try a couple of problems on this third side here. Again, this is the same type of diagram. We're looking at a big right triangle here with an altitude drawn to the hypotenuse of the big right triangle. And it says that BO is 3 root 2, BY is 3, find BX, which is, we'll call it X. And so, again, sun here, shining down this side, so it's going to be 3 root 2 squared is equal to short shadow, which is 3 times the long shadow, which is x. Now here's why I wanted to bring this problem up. I want to make sure that we are doing this correctly here, because sometimes what students will do is they'll stick this in their calculator and they will get 6 for the answer, and that is not correct. Okay, you need to put this in parentheses first of all, and so it's going to be 3 root 2 times 3 root 2, and 3 times 3 is 9, root 2 times root 2 in this case is 2, and so your answer is 18. So 3 root 2, the quantity squared, is 18. So it's going to be 18 is equal to 3x, or x is equal to 6. Okay, so make sure that you are not making that mistake when you are doing these problems. Okay, let's do number 5. That'll be the last problem we do here. So SR is 16, PQ is 15, find PS. So sometimes you're going to end up with some 15 squared is equal to x times x plus 16. Hopefully you can see what's going to happen here. You're going to end up with a quadratic. So distribute that, get 225 is equal to x squared plus 16x. bring everything over to one side, set it equal to 0, plus 16x minus 225. Factor it, like we've been doing all these problems throughout the year, so x plus 25 and x minus 9 equals 0. Zero product property it, negative 25 and 9. Hopefully you can see that there's no way that that side length is going to be negative 25. So 9 is going to be your answer there. Okay, I'm going to stop here and give you a shot. You don't have to use Sunshine if you don't understand what Sunshine is, but you are welcome to use it. I use Sunshine. I think it works. If you have any questions about it, feel free to ask me about that. Okay? Good luck trying these problems.